Today we're talking about sequences that follow the recursive formula. You'll recall that a sequence is a string of numbers that follows a pattern. There are two kinds of sequences, arithmetic and geometric sequences. Today we're only talking about arithmetic, which are sequences where you find the next point by adding. A recursive formula is one that's based on the previous term. So we have our formula here. It's all based on the first term, our a1. And then you would use the formula here. A sub n is equal to a sub n minus 1 plus d, where d is our common difference, or the amount that we're adding to the next point. Now I get that the a of n equals a of n minus 1 plus d looks kind of scary, but in practice it's really not that bad. For example, a of 2 would be a of 2 minus 1 plus d. Now we should be able to do the math 2 minus 1 in our head, meaning this is going to be the same thing as a of sub 2 is equal to a of 1 plus d. Now we should know what a of a1 is based on we're already told our first term. We could do the same thing for a of 3. And a4 works the same way, and so on and so forth. Now let's go ahead and work our way through these 4 examples on this first page. We have a of 1 is equal to 10. We've given the recursive formula. Notice our common difference in this case is 5. And we're told that n is bigger than 1. That's not particularly remarkable to us. You'll recall that sequences only deal with positive n values. So let's go ahead and work our way through it. A of 1 is equal to 10. A of 2 is the same thing as a of 2 minus 1 plus 5, which is a1 plus 5, which would become 10 plus 5, or 15. Similarly, a of 3 would be the same thing as a of 3 minus 1 plus 5, which would become a2 plus 5, which would become 15 plus 5, or 20. Keep going. One more. A of 4 would equal a of 4 minus 1 plus 5, which would become a of 3 plus 5, which would become 20 plus 5, or 25. Meaning our sequence would be 10, 15, 20, 25. Now we're told to identify the next 4 terms, and we currently only have found out 3. So we could go about finding the next term by following the same formula. Without doing the math, I'm going to take a guess and say that's going to be 30. All right, next example. We're just given the series. The sequence, sorry. We aren't told about what the formula is. So let's see if we can figure it out. 36, 27, 18, 9. It appears that we're adding negative 9 each time, so our d is going to be negative 9. And our first value is 36. So if we were to write that with the recursive formula, it would be a of n is equal to a of n minus 1 minus 9. We were told to find term 5. We can go ahead and skip right there. We have our 4th term, our a4 term. We can simply plug that into the formula. a5 is equal to a5 minus 1 minus 9, which would be the same thing as a4 minus 9, which is 9 minus 9, or 0. Now, frequently sequences are represented by pictures, not numbers. It works basically the same, but instead of numbers, there are pictures. So let's go ahead and just count the number of toothpicks in each of these pictures. This one looks like it's got 4, this one's got 7, this one's got 10, and this one's got 13. I'm just counting the number of lines there. So let's go ahead and figure out a recursive formula. The first term is 4. And it appears that we're adding 3 toothpicks each time. So our common difference is 3. Meaning our formula would be a of n is equal to a of n minus 1 plus 3. Now we're told to find term 5. So that would be a5 is equal to a4 plus 3. Our fourth term has 13 toothpicks, giving us a5 is equal to 13 plus 3, which would be 16. All right, we'll go ahead and do the last example. Julia makes $5 an hour. Let's go ahead and just list out how many she would make. So in the first hour, she'd make $5. In the next hour, she'd make 10, and so on, and so forth. This is one of those cases where we're going to start with our first number. Sorry about that. Start with our first number, 5, and keep going. So A1 is equal to 5. And our common difference is 5 as well. So we want to figure out what term 5 would be. So we already figured out that the fourth term would be 20. So we could simply plug that into our formula. A sub n, which in this case n is 5, is equal to a5 minus 1 plus 5, giving us 25. I'm going to go ahead and specify dollars just to keep it in the context of the problem. Now your homework is more of the same, with one exception. You are asked to graph out a recursive formula. It's not too bad. Just go ahead and figure out what your values are and then scale your y-axis appropriately to make them fit. So let's go ahead and just look through number 11 really quick. Claire uses her rattle cards at the school store to buy pencils. She initially had 2 pencils, week 0, and begins to purchase 5 more each week. So we're told that week 0, or our first term, is 2. And then each week we go on and we buy 5 more pencils. So our formula would be a sub n is equal to a of n minus 1. That's too big. I'm going to make that a smaller one. Plus 5. So there's our recursive formula. Let's just go ahead and list out some values really quick. I'm just simply adding 5 each week. I'm going to go all the way up to A6 just to be sure. Okay. So now let's go ahead and plot our points. We have to pick an appropriate value for the y-axis. I'm going to make these darker lines 10s, I think, because we don't go higher than 30. So let's go 10, 20, and 30. So our first value, which means our smaller lines, 2, 4, 6, 8. So that'll be 2. Oh, we'll do that in green, I think. And then our next value becomes 7, 12, 17, 22, 27, If we were to answer the last question, how many pencils would she have in her 6th week? It looks like we'd have to go one more, which would be 32 pencils. As always, let me know if you have additional questions.